a little review of some of your exponent laws from grade 9. If you have the same bases and you're multiplying, you add the exponents. So this can happen with variables. This will equal y to the 5. It can happen with numbers. But as long as the bases are the same and you're multiplying two powers, then you can just add the exponents. Review number 1 of our exponent laws from grade 9. If you have a power of a power, you multiply the exponents. And we looked at this the other class, the reason why this happens. Again, you might have 2 cubed to the 5. Can you imagine 2 cubed 5 times? And if you imagine each of those 2 cubes as 2 times 2 times 2, and you have 2 times 2 times 2, 5 times, can you see why there would be 15 2's in the end? So this can work whether your base is a number or if your base is a variable. Power of a product says when you have an exponent to two things, so if I have xy cubed, well, again, you imagine, here, this is what you imagine in your head. Xy cubed means xy multiplied by itself 3 times. And then it should make sense why there's the 3 would go to the x. You would have x cubed, and you would have y cubed. This works if you have numbers in there as well. This also works if you have a negative in there. What happens when you have a negative to an exponent of 4? It becomes positive. Then the 4 also goes to the 2, and the 4 goes to the x. And of course, it doesn't have to be two things. Let's say you have 2abc squared. Well, 2 squared is 4, a squared, b squared, c squared. You could have more than two things inside and have a power to a power. And the last law from grade 9 was the quotient rule. Oh, I didn't have the quotient rule. I should have the quotient rule separate and then have a power of a quotient. No, I did have a quotient rule separate. Did we just skip it? Yeah. Why did we skip it? We don't know. There it is. We'll go back to it, and then we'll go to the power of the quotient. So if you are dividing things with the same base, and this is true if they're numbers as well, you can subtract the exponents. Why does that work? Well, if you think of here in green, 3 to the 7 is 3 times 3 times 3 times 3 times 3 times 3 times. That might have been 7. And you divide it by 3 to the 5, which is 3 times 3 times 3 times 3 times 3. Well, if you were simplifying, they would all cancel out, except you would be left with 2 on the top. And so if you think about what an exponent means and you think about simplifying, it becomes obvious that I'm left with 3 squared. Well, why do we subtract? Because we're going to have all 5 of those cancel out. Now you could two different ways you could do this one. 4 cubed divided by 4 to the 5. You could imagine it in green again. Well, you don't have to imagine in green, but if you like green for imagination, then that's fine. You could imagine you have 3 4s on the top, 5 4s on the bottom, all the canceling happening. What would you be left with? You would be left with 2 4s on the bottom. So you can imagine that that answer is fine. If I subtract the exponents, 3 minus 5 will get me negative 2, and then our negative exponent law shows up again. Oh, and finally, the power of the quotient means that if you have a fraction and it's squared, the top will get squared and the bottom will get squared. Which makes sense because squaring means you multiply by itself. And how do you multiply fractions? Right? If squaring means multiply by itself, and multiplying fractions means you multiply your numerators and you multiply your denominators, then it makes sense why that power goes to each one. And we're going to find out that these rules, well, they work even if you have fractions as exponents. What did the 1/2 mean again for a fraction? Square root. So this is the same as square root of 16 over square root of 25, which you could simplify to 4/5. So the rules that we have, which make sense when we think about whole numbers, because we can think about the definition of what an exponent means and understand why these rules work. But these rules can be extended when we're working with decimals, negatives, fractions. So here I've got 0.6 to the exponent of 3 multiplied by 0.6 to the exponent of negative 8. The question is asking us to simplify by writing as a single power. While here we're multiplying with the same basis, so we can add the exponents. And if I add 3 plus negative 8, I'm going to get negative 5. This one was straightforward, just one power rule. We're also going to start to get questions that combine multiple exponent rules together. So the fraction to start with, the base is negative 2/7. That really shouldn't bother you too much. Okay? We want to write this as a single power in the end. And we've got negative 2/7 in both cases. So I've got, in the first part, negative 2/7. What's the rule when you have a power to a power? We can multiply. Divided by, and we have another power to a power, we can multiply. And now we have one base divided by another base, and the rule for dividing is that you can subtract the exponents. I'm going to write it out completely because it would be negative 12 subtract negative 10. And so also what comes into this is our understanding of how to work with integers. What is negative 12 subtract negative 10? Negative 2. Now, often in textbooks, in the answer key, they don't like writing things with negative exponents. So if this was written as a positive exponent, you could do that. That was one of our rules that we found out with the negative exponent, that we could do the reciprocal and write it with the positive exponent. Okay? And if you wanted to write this one as a final answer, well, 7 squared is 49, and negative 2 squared would be 4, and it would be positive because when you square a negative, it becomes positive. So I'd like you to try the next two. I'll put the answers up in a bit. Okay, let's see how you did on these first two. So first of all, a power to a power, you would get 2.7 to the negative 15 over 2.7 to the 4. Our bases are the same, so we can write this as 2.7 of negative 15 minus 4, which is 2.7 to the negative 19. How'd you do? Okay. Last one. We've got a base of 9 happening in a bunch of places, and our exponents are all fractions. In our numerator, we're multiplying with the same base. So in our numerator, we can add our exponents. What is negative 1/4 plus 5/4? 4/4. Now, 4/4 is the same as 1. Why might I want to leave it as 4/4 though right now? Because the next step I have to subtract. And if I want to subtract fractions, I would need the same base anyways. So when I subtract 4/4 minus 3/4, my final answer is 9 to the 1/4. It's another way that I could write 9 to the 1/4. Okay, yes. What another way first? 4th root of 9. So I wanted to see 4th root of 9 first. And then Thrindu said, that's the same as the square root of 3. How did he do that? Would you agree that 9 is the same as 3 squared? So if I had, so this is the question, how did he get from the 4th root of 9 to the square root of 3 and the fact that those are the same? Well, if I have 9 to the 1/4, 9 is the same as 3 squared. And then if I would have a power to a power, I would multiply. How do you multiply fractions? You multiply your numerators, you multiply your denominators, and you get 3 to the 2 over 4, which simplifies to 3 to the half, which is the square root of 3. So we have more than one way that we can represent things. So the answer could be left as 9 to the 1/4. It could be written as the 4th root of 9, and it could be written as the square root of 3, or 3 to the 1/2. Those are all the same. Often in a question, they'll say, write your answer with fractional exponents. Then you could leave it as 9 to 1/4 or 3 to the half. That would be fine. Or the question might say, write your answer as a radical. Then you would have to change it to the 4th root of 9. Okay, there are another 6 to simplify. Again, I'll give you a head start. So in the first one here, we're all multiplying. Now, you don't have to do this as a first step, but multiplying doesn't matter the order. So I could have had the a cubed times the a to the 5, and then the b7 times the b to the negative 3. And sometimes if you arrange them that way, you can see the rule, the exponent rule, a little bit easier. What's our exponent rule? When we're multiplying with the same base, we add the exponents. So this becomes a to the 8, and adding the exponents here, this becomes b to the 4. Now you don't need that step in between, but sometimes rearranging things like that helps you see the rule even better. Sometimes I rearrange things and just imagine them, and then I can see the rule, and then I apply it right away without having to write it. Now, the exponent rule for dividing is subtracting. Okay? But I've got numbers here as well. So our numbers would need to be simplified as well. The fraction, 8 over 12, could you write that in lower terms? What number divides both 8 and 12? Is 4. So if you simplify it 8 over 12, it becomes 2 over 3. Now, if you imagine those expanded and you cancel things out, or if you subtract the exponents, can you see that you would be left with x cubed on the top? And if I expanded the y's, I would have 4 more y's on the bottom. I would have y to the 4 on the bottom. Now, if you subtracted your exponents, did you get, how many people got y to the minus 4? Okay, that's perfectly fine as well. You will find that textbooks tend to write their final answers with all positive exponents if they can. So your textbook answer would probably be the one in blue, but the one in blue is the same as the one in green. Just using your negative exponent law, saying if you have a negative exponent, you could rewrite it by doing the reciprocal. So this one was in the numerator with a negative exponent. You could write it in the denominator with a positive exponent. So we have a power to a bunch of things, an exponent to a bunch of things. That means that that exponent of 3/2 would go to each of them. It'll go to the 25. That exponent of 3/2 will go to the a to the 4, and that exponent of 3/2 will go to b to the squared. Now, I wrote it like that separately so that we could say to ourselves, well, what happens when we have a4 to the power, or to the exponent of 3/2? We have the power of a power, so that means we're going to multiply our exponents. So a to the 4 becomes a to the 6. Can you see that if you multiply those exponents, you would get 12 over 2? You can imagine the 4 is 4 over 1. How do we multiply fractions? We multiply our numerators, we multiply our denominators, and we would get 12 over 2, which reduces to 6. Same thing in the next one. You can imagine that 2 is 2 over 1. If you multiplied, you would get 6 over 2, which reduces to b cubed. The last thing we need to do is simplify the number 25 to the 3/2. So what I would do here is I would probably do the square root part first, and then cube it afterwards. Square root of 25 is 5. 5 to the exponent 3 is 125. So that's what our final answer would look like. So one of the things we start to notice in grade 10, and this is true moving forward in all of your pre-calculus and applied classes, is now we're expecting you to be really good at all of your rules with fractions and really good with all of your times table and square roots and powers, so that we can work through a question like this that has some fractions, but focus on what we're learning that's new and not get hung up or make mistakes on some of the stuff that you've learned in the past. So if the fraction stuff is getting to you, that means take some time, think about fractions, practice some fraction rules. Again, you want all of your mathematical ideas to make sense. Even the exponent laws. If you just memorize exponent laws, you're going to mess them up a lot once things get more complicated. If you can go back to your basic exponent laws and think about what they mean and they make sense to you, then you're going to find that you're going to make less mistakes when you're dealing with fractions and decimals. So in D, again, I'm just going to, this is all multiplied together. I'm just going to rewrite it with my x's right next to each other and my y's right next to each other. This is going to help me see, oh, I'm multiplying things with the same base. The rule is that I add the exponents. So 3 plus a negative 1, that will become x squared. And negative 3 halves plus a half, well, I'll write it like this to begin with. Negative 3 halves plus a half will be negative 2 over 2. And then in most textbooks, the final answer here would be written as x squared. And y to the negative 1 would go to y to the 1 in your denominator. So it becomes x squared over y. So looking at the numbers 12 over 3, they'll simplify to 4. We're dividing, so if we have the same bases, we can subtract the exponents. So right now, I'm going to write, on the top I have negative 5, and I'm going to subtract. On the bottom I have a half. And for y, in my numerator I have 5 halves, and in my denominator I have a negative a half. So I'll just show the subtracting that way. Because they're fractions, the mental math isn't as easy just to write the answer right away. How do I subtract fractions? I need a common denominator, so 5 is 10 over 2. So if I have negative 10 over 2 minus 1 over 2, I will get negative 11 over 2. And if I have 5 over 2 minus 1 over 2, minus a negative 1 over 2, that's the same as adding. That'll give me 6 over 2, which I'll write just as a 3. So the final answer in the textbook, they may move that negative exponent to the denominator, in which case your final answer will be 4y cubed over x to the 11 over 2. And our last example.
In the question x, like x to the half is positive.
This x to the half is positive.
Oh, yeah.
Yeah. And then but we would subtract it because of our exponent rule. That's good? Now, a question like this, you have inside the brackets a bunch of exponent laws. We also have the half outside of the brackets as an exponent law. So you have some choice in which exponent law you would like to do first, right? We could simplify inside first and then apply the half, or we could apply the half to everything first and then simplify afterwards. So sometimes when you have choice, sometimes what you have to do is try to do a little bit of mental math inside your head first and say, what would it look like if I did this exponent law first? Think about it. Then say, well, what would it look like if I did the other exponent law first? And in this case, I think by thinking about that, you'll see it makes more sense to simplify inside the brackets first and then apply the exponent of 1/2 afterwards. So if I simplify inside the brackets first, so that 1/2 is going to stay out there, 50 divided by 2 is 25. Can you see that you would have more x's on the bottom, so x squared, and more y's on the bottom, so y cubed? And if you wrote this as 25x to the negative 2, y to the negative 3, that would be fine as well. And now that I've simplified it, now I can say my exponent law of having that half outside of a fraction, that 1/2 will go to everything. What happens when I do the 1/2 to the 25? Are you okay if I just write 5? Because the 1/2 is a square root, and the square root of 25 is 5. The x squared to the 1/2, well, you'd have to multiply. I'm going to write that as 2 over 2. but probably you could tell mental math-wise that that's going to be 1. And y cubed to the 1/2, that'll be y to the 3/2. So my final answer here, when I simplify this, will be 5 on the top. X to the 2/2 is just x times y to the 3/2. So again, watching me do them, probably you can go, okay, yeah, that makes sense. But what we really need to do is practice these ourselves, because you're going to find that, you know, if you have a little bit of gaps in your fraction work, or your mental math, if you don't have a super high focus right now, you're going to make lots of mental math errors. You're going to check the answer in the textbook, and you're going to find out, ooh, I've made a mistake. So these questions require a fair amount of focus, and you're combining a lot of straightforward math rules from middle years, adding fractions, power laws from grade 9, all of those things get combined. So you have to stay focused to make sure that all of your numbers work out in the end. So we're going to take some time now to practice these. If you finish these out of the textbook, there was the worksheet that I gave at the end of class on Friday after the quiz. You can work on that as well.